Okay, so we're going to be doing the 2021 AMC 10B problem number 11, and it's time for some brownies. Grandma, we all love Grandma, has just finished baking a large rectangular pan of brownies. This is why we all love grandmas, really. She is planning to make rectangular pieces of equal size and shape with straight cuts parallel to the sides of the pan. Each cut must be made entirely across the pan. Grandma wants to make the same number of interior pieces, which are my favorite, as pieces along the perimeter of the pan. If you like the perimeter ones, you can mention it in the comments, but if you've never had brownies, you're missing out. I'm not sure if all cultures enjoy brownies, but if you haven't enjoyed it in your culture, you should bring it to your culture. It should be great. Every culture should enjoy brownies, in my opinion. What is the greatest possible number of brownies she can produce? If you don't even know what brownies are, maybe you don't, another country, there's some international students taking it. I don't know how widely known the idea of brownies are. It's basically a delicious form of chocolate, and you get to eat it. And yeah, you can look up images or videos probably on YouTube about how to make brownies if you want to make them wherever you may be located around the world. Okay, so in the US we just go and buy a box and it's like got all the ingredients in it and boom, brownies. It tells you what ingredients you need. I don't know. I haven't made brownies before. I just like to eat them personally. Okay, so the greatest possible number of brownies she can produce. Here we go. So we're going to have a rectangular pan, like so, and you're going to cut the edge inside like this. And I'm going to say that it has inside length L and inside width W. And since the edge brownies consist of only a thickness of one brownie, because they're on the edge, this would be a distance of 1 in terms of brownie squares. And this would be a distance of 1, making the outer rectangle L plus 2, and similarly this one is W plus 2. Now, what does she want? She wants it so that the same number of interior as the perimeter. Well, how many perimeter pieces are there? It's kind of like concentric circles. Maybe you could call it concentric rectangles or something like that. It's not really a word, I don't think, but maybe it is. You're going to do L plus 2 times W plus 2. That's how many brownies would be in the whole pan altogether. And if I now subtract the interior brownies, which will be LW, I would have this represents the edge brownies. And those are pretty good too. I mean, I kind of like all brownies, really. And then this would be equal to the interior. So the edge brownies equals the interior brownies. Okay, so L times all of this, L times W, we're going to get LW, and L times 2 is 2L, and 2W, and 4, and this LW and that LW cancel, because that's a minus, this is a plus, and this will equal LW. So now what do? We got this equation. We know that L and W are going to be integers because they represent like the number of brownies, like edges that you would have, and you can't have a partial edge, right? They're all the same size. So what can we do? Well, we're going to have to see what Simon says, which if you go on the AOPS forums or you've done the Intro to AOPS series, you know what I'm talking about. We're talking about what we call Simon's favorite factoring trick. And you can look it up. It's probably even on the wiki on AOPS about how it works. And maybe find some practice problems on there. I'll try and look at some point and add it to the description, and we'll get it in there. But for now, what is Simon's favorite factoring trick, and who's Simon? Well, not every formula or concept has some, famous mathematician's name on it. Simon has become probably most famous for having his favorite factoring trick. And it was contained in one of the AOPS books, and now it gets called that all the time. And to be honest, I get why Simon likes it. It's kind of fun. So LW, you're going to move it over here. It's 2L. I'm going to subtract the LW, and then I'm going to have plus 2W, and I'm going to move the 4 to the other side, equals negative 4. Now what? Now you're going to factor out this L, and you're going to get L times 2 minus W. But why? Why would we do that? Well, if we can make another 2 minus W here and something factored out, but we don't have enough stuff to do that, we can fix that. You have the control to add whatever you want to both sides of the equal sign. And so, how am I going to get a minus w by factoring something out of this? Well, there's only one way. You have to factor out negative 2. So now we're just going to look at what would I have had right here in order to factor out the negative 2. Let's just distribute and see. Negative 2 times 2 would have been negative 4 plus 2w. So if I had a negative 4 here, I could do this. But I didn't. But now I do. And now you can also put another negative 4 over here. And now what? We've got negative 8. This will now equal negative 8. And I can pull the 2 minus w out. So I'm going to have 2 minus w times L minus 2 equals negative 8. Nobody really likes negative numbers. They're like negative people. We don't really like negative people either. And as such, I would like to not have this negative here. So I'm going to actually move it over here. And we're going to distribute it to the 2 minus w. It will simply switch order. W minus 2 times L minus 2 equals 8. That's better. Now, we know w and L are integers, and all we have to do is think of factors of 8. They could be 8 and 1, 4 and 2. That's about it. So what's what? It doesn't really matter. They're just playing the same role. So pick L to be not 8. Don't pick 8. If you picked L to be 8, sad day. Instead, the expression in parentheses has to take on the value of 8. And as such, the L would need to be 10. And then if this is going to take on the value of 1, what does W have to be? W has to be 3. Now, that would mean that the length times width on the inside is 30. Let's see if this worked. Did it work? Did we make some kind of mistake? Did I actually execute Simon's favorite factoring trick correctly? Well, we just have to check, right? Plug the 10 into the L. You will now have 12 times. Plug the 3 that we found, 3 right here, not blocking it, into the W. You get 5. 12 times 5 is 60. Sure enough, the inner brownies are the same as the outer brownies. 60 is a pretty good answer. We just might wonder, is there any way to get 64? What if I changed it and tried this one? If you're going to try this one, 4 would be one of these, probably the, not the L, but the expression with L in it. And you would have gotten L equals 6, because 6 minus 2 is 4. And W would take on the value of, what, 4. And if you did that one, you would have gotten 6 plus 2 is 8. For this one here, and 4 plus 2 is 6, and sure enough, 8 times 6, 48, 24 is half of that. That fits all the criteria, which is why it works. However, it's not the greatest possible number of brownies. We don't want 48 brownies, you want 60. And you can't get the 64, so the answer is D. Let's get to problem 12. Alright, so we are on now the 2021 AMC 10B problem 12. It was also the 12B problem 7. I kind of like this question a lot, mostly because I didn't know what to do, but I figured it out, and I'll show you how I did that. Let n equal 34 times 34 times 60. What is this? Okay. What is the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? Well, I knew that it probably involves prime factoring, because that's going to give you something about the number of divisors, so let's go ahead and do that. When you don't know what you're doing, just start finding new pieces of information and see if you can think about those new pieces of information. So you're going to have from the 34s 2 squared times 17 squared. The 63 is going to have a 7 and a 9, which is 3 squared. 27 times 10 is going to be 3 cubed times 2 times 5. So then now we can say finally that n is going to be 2 to the 3rd times 3 to the 5th times 5 times 7 times 17 squared. Okay, that's a lot. I really don't want to find all those divisors, and I certainly don't want to add them all up. So that must mean there's some kind of underlying process going on that we can capitalize on. But we don't know what that process is, so what do? Well, we give up and skip. Or you don't. And if you did and came back to it, that's fine. Maybe you got other questions later or something like that. It's not always wrong to skip, but you should at least give it, I don't know, peek a little farther down the road. What I did was this. I said, well, let's just say n wasn't this. Let's say it was 12. If I did n was 12, okay, what are all the divisors? 1, 2, 3, 4, 6, and 12. Okay, what is the sum of the odd divisors? 1 plus 3. The even divisors is 2 plus 4 plus 6 plus 12. What is that equal to? 4 over 6, 12, that's going to be 24. It's going to equal 1/6. Why 1/6? I couldn't tell quite yet. What about prime factoring 12? It's 2 squared times 3. Is it because 2 times 3 is 6? Don't know yet. Let's get another example. Let's do 18. 18 is 3 squared times 2. So the divisors that are odd are going to be 1, 3, and 9. So you'd have 1 plus 3 plus 9. And the even divisors are 2 times all of those. Maybe there's something going on here. 2 plus 6 plus 18. I can see if I factor out a 2, I'm going to get 1/2. And that makes me think. Let's see if we can see one more example, and maybe you can figure out what's going on. 24 would be 2 to the third times 3. The only odd divisors of that whole set of 24 is 1 and 3. So if I did that, the sum of the odd divisors would be 1 and 3. I try to pick things with multiple different powers of 2 in them. That's what I chose for my exploration. 24 has 3 powers of 2, and that's what we have, so maybe it'll help. So 1 plus 3, then I have to do what? How am I going to get the even divisors? Well, if I do 2 times these, I'm going to get 2 plus 6. Then I'd also have to do 4 times them, so I would get plus 4 plus 12, and then plus 8 times them, because 8's another even divisor, power of 2 divisor, and so you're going to get 8 plus 24. Now, that makes me think, what did we just do? How did we get the even divisors? This one here blew it open for me. I could see it after this, but I had to get this far. 1 plus 3, if I factor out this 2, it's just reversing what we just did. We said it was 2 times 1 plus 3. I'm not going to have space there, so I'm going to go this way. And then these ones we got from 4 times the odd divisors, right? So you're going to have 4 times 1 plus 3, and then you're going to have 8 times those odd divisors. 8 times, not plus, 8 times 1 plus 3. Now, there are no other even divisors, right? This is going to be all of them. Can you find any even divisors that are not amongst these? You're not going to be able to, right? We've got 2, 4, 6, 8, 10's not a divisor. 12 is, and anything higher than 12 except for 24 won't be. So we've definitely done it right, and what you can see is whatever the sum of the odd divisors was, you've got that here, which means you could cancel it. You're going to get 1 over 2 plus 4 plus 8. That is 1 over 14. And here's the kicker. You can perceive it doesn't matter what the odd divisor sum was. What you're going to get is always going to be, that's called the odd divisor sum D. You're going to have D over, and then all of the powers of 2 need to distribute to all of the odd divisors, including 1, which is why you're going to get the 2, 4, and 8 as well. And so you're going to get 2 times D plus 4 times D plus 8 times D, and it doesn't matter what the odd divisor sum is, which is why we don't care what our odd divisor sum is. It stands to reason that for every odd divisor, you can multiply it by 2 to get an even divisor. And if you have 2 powers of 2, like we did here, you could multiply it by, or here, you could multiply it by 4 as well. That's why we've got 4 times 1 and 4 times 3 is the 4 and the 12, and 2 times 1 and 2 times 3 is the 2 and the 6. This had the same rule. That's why it's a 6, because it was 2 plus 4, the sum of the powers of 2, one at a time. So 2, 4, 8, if there had been 4 powers of 2, you would add a 16. And if you check this one as well, that's why we got 1 over 2, because there was only one factor of 2 in the prime factorization, so we could only distribute 2 one time to all the odd divisors. This is what it is. Since we had 3 powers of 2 in our example with 24, the answer for this one will also be C. Let's go to problem 13, and also for the 12B, problem 8. All right, so now we are on the 2021 AMC 10B problem number 13. Let n be a positive integer and d be a digit, which is a integer from 0 to 9. but we'll see, such that the value of the numeral 32d, so that is going to be 3n squared, in base n. So 32d in base n. All base n means, think about base 10. Even if you don't know number theory, you can at least understand how bases work, and you might get these kind of problems. If I have 417 in base 10, that's 4 times 100 plus 1 times 10 plus 7. And you can think of it as 4 times 10 squared plus 1 times 10 to the first plus 7 times 10 to the 0, where these numbers here are the powers of 10 starting from 0. So we'll do the same thing here. This will be n to the 0 power, n to the first power, n to the second, hence 3n to the second plus 2n plus d. This is going to equal 263. The value of the numeral 324, that's very similar to this, 3n squared plus 2n plus 4 in base n is equal to the value of this numeral in base 6. So this will be 1 times 6 to the third, that's 216. You should memorize your perfect cubes up till about 12. This will be 6 squared, like again, it's 6 to the 0 space, 6 to the first, 6 to the second, 6 to the third. So then 6 to the second is 36, 6 to the first times d, we don't know what d is 6d, and then plus 1. 252 and 1 is 253 plus 6d. Now, we're trying to find n plus d. I think you probably want to subtract because it makes the n's go away. So if I take this and subtract, you will get d minus 4. 263 minus this bottom expression is going to be 10 minus 6d. 6d over to get 7d, 4 over to get 14. d is 2. From that point, we're just going to come up here and plug it in, subtract 263. You now have 3n squared plus 2n minus 261 is equal to 0. 2 plus 6 plus 1 is 9. That means it's divisible by 9. Indeed, 9 times 30 is 270. But this is 9 below that, so it would be 9 times 29. And why do we do that? Well, because we're probably about to factor, and we need to have something broken down besides 261. We could also pull 3's out of this if we need to do 3 times 87. 29 is prime though, so it's done. We're going to have 3, so that has no choice. It must be 3n and n. And then now we're going to have to do placement of this. If I do 3 times 9, I will get a 27, and the other factor of 1 times 29 will give me a 29. If you think about those two numbers, 29 and 27, they have a difference of 2, which is exactly what we want. Therefore, the 9 of the divisor of this, the 9 will go here, and the 29 will go here. That will allow me to create a product of 29n and 27n, of which I want the 29 positive and the 27 negative. So that goes here and here. Therefore, n is equal to 9 because it's not this, not that at all. Then we got n is 9, d is 2, 9 plus 2 is 11. That's answer choice B. Got it. We're on to 14. Hi guys, it is now Thursday morning in America. The day, I'm sure it is that way everywhere, just about, except China, where it's Chinese New Year. Happy Chinese New Year. More on that in a later video today, I hope. But for now, it is 2021 AMC 10B problem 14, which was also the 12B problem 8. Sorry about the light coming through my blinds from, it's early morning now, trying to get these filmed before I have to work later today, as many as I have time to do. And so I could put a blanket over the window, but I don't know. I don't have time for that. We gotta get filmed, right? So you'll have to deal with the limited aesthetic appeal, but I don't feel like it's gonna interfere with our understanding too much or block diagrams and things like that. We'll see. I'll refilm if I have to, I guess. 3 equally spaced parallel lines intersect a circle, creating 3 chords of lengths 38, 38, and 34. So how do you get 2 chords of equal length? Only if they're the same distance from the center. So if I go like this, we'll put a pretty big circle here, I guess. That's not that bad looking of a circle. Could be a little bit more round down here, I suppose. It's kind of hard drawing from the side. You're not drawing straight on, but it's good. Okay, so center here, okay, and we're going to have two chords. They have to be the same distance from the center. So I'm going to call that distance perpendicular distance. The distance from a point to a line is always measured perpendicular. That's going to be d. We don't know what it is. And this distance here, let's say it was here instead. This distance here is also d. Okay. So the other one's 34, which means it's farther from the center, but it's equally spaced, so probably should have been, whatever, we don't really care. It probably should have been tighter into the center, but that's what happens. Just pretend, right? And, oh, but it actually isn't that, yeah, that's right, yeah. So then this is going to be a distance of 2d because it is... the distance between these two lines is 2d, so the distance between these two lines is 2d. Why? Because they're equally spaced parallel lines. Okay, now what? What is the distance between the adjacent parallel lines? In other words, what's 2d for our problem at least? Your problem might have looked different, or somebody else's might have looked different. How are we going to get that? Well, you're in a circle. And if I was playing the role of Sherlock Holmes or something, I'd probably be asking myself how the radius comes into play. That is the most significant feature of a circle. In fact, when you think about circles, you should immediately think, what's the radius? Where's it located? How do I use it in this problem? Because the radius is always the most important thing of a circle. It's part of area, it's part of circumference, and maybe several other things. But always think about the radius. I mean, not when you're not thinking about circles. I mean, that'd be weird if you're like, trying to eat a pizza and you're like, radius. No, that would be weird. Don't do that. Just when you're thinking about circles, always think about the radius, right? So what are we going to do? We're going to draw, if this is 38, when you connect the center of a circle perpendicular to a chord, you bisect the chord. So these will be 19, 19, 19, 17, and 17. And then furthermore, now we're going to draw that radius we talked about. We're going to draw it over to the edge. And when we do that, we get Pythagorean. And so now you're going to have d squared plus 361, which is 19 squared, is equal to r squared, because the radius is the hypotenuse of this triangle right here. You're also going to do that going up here. Why not? Because where else are you going to draw? Are you going to draw, oh, I wonder if I draw the radius out here? No, don't draw it to a random place, man. Draw it to a place that could benefit. And so this is going to be 17 and 3d, and you're just going to square those lengths. You're going to get 9d squared, which is basically 3d squared. And then you're going to get plus 289 is also going to equal r squared. Now, we don't want to actually know what r is, so let's just subtract and get rid of it. So if I do 361 minus 289, add 11 to get to 300, and add 61 more to 11 to get 72. Don't subtract. 72. This will be 72, and then I'll have negative 8d squared plus 72 equals 0. Let's move the 8d squared over to the other side. So we get 72 equals 8d squared. How is that? Can you see that on the... It's on the thing. Maybe I should put it over here just in case. So 72 equals 8d squared. And then you're going to divide by 8, and d equals 3. And that's not the answer. That would have been so good if they put it here, huh? Probably would have got several of you guys. But for us, we're lucky. 2D is what we're looking for, and 2D is 6. 2D is 6. Let's get to the next problem. All right, so as the morning progresses, I'm going to be having these dots here. I don't have time to hang a blanket. I have to nail into the wall, and we rent, so I can't really do that. There's nothing to hang the blanket on, so I don't know how to block those from showing up in the window. We're going to have to deal with it, I guess, or I can't film. So 2021 AMC 10B problem 15. the real number x satisfies the equation x plus 1 over x equals root 5, what is the value of this? Now, I strongly suspect there's going to be a fast way to do what I'm doing, like some kind of cool shortcut using some special technique named after somebody who's no longer alive, but that's not what I did. I just kind of bashed it out. But if you're good with binomial expansion, it goes pretty quick, and it's like less than 5 minutes of a problem, which is a really good time for a problem 15. So first off, when you see this, you should strongly suspect golden ratio. And if you don't know what golden ratio is, learn about it. It's going to be that it's phi, basically, and it's equal to 1 plus root 5 over 2, which is approximately 1.61803, and it keeps going a long ways, like forever actually, because it's irrational. So then let's go ahead and solve this and verify we get something like that, or see what we can do with it. Solve it for x. How it's going to work, you're going to multiply by x to get it out of the denominator. We don't want it there. Then you're going to, I wonder if we could do that. If we set x equal to root 5 minus 1 over x and plugged it, I don't think that's going to help. Let's just do it this way, right? So times x, you would get x squared, and then this is going to have an x on it. We're going to move it to this side so it becomes minus root 5x. The x is not inside the root 5. This no longer has an x on it because we multiplied by x, so it's plus 1 equals 0. We'll just do quadratic formula. So negative b is root 5 plus or minus the square root of b, which is here, squared. That's 5 minus 4 times a times c, which is 1, all over 2. Sure enough, one of them is the golden ratio. So you've got root 5 plus 1 over 2. You also have root 5 minus 1 over 2. At the time of this filming, I have not explored why this one doesn't end up working. Like, it's one of the solutions to this if I plug it in, but it doesn't actually tell us one of the answers here. Yeah, so because it seems like it should have been also have worked. I don't understand why it didn't at the moment. I'll probably figure it out later when I have time. But I did try this one in here, and it doesn't. Maybe I miscalculated. That's possible too. This one definitely works though, so we're going to use it. And how's it going to work? Well, here's what I did. I took this x to the 11th expression, and I'm going to factor out x cubed. So now I've got x to the 8th minus 7x to the 4th plus 1. And that gave me an idea. It's like, well, this is x to the 4th and this is x to the 8th. That is simply that squared. So maybe we should just do binomial expansion. Yeah, you have to. Maybe there's other ways again, but this is what I had to do. So binomial expansion works like this. If you've got a plus b to the 4th, you're just going to take Pascal's triangle, 4th row below the top row, which is 1, 4, 6, 4, 1, which are combinations, but more on that a different time. And you're going to have 1, 4, 6, 4, 1. And all you're going to do is the first thing you have, the first part of it will go to the 4th power here. A to the 4th, and it's just going to count down. A to the 3rd, a to the 2nd, a to the 1st, and no a on the end, or a to the 0. And then you'll have b to the 1st here, b to the 2nd here, b to the 3rd here, and b to the 4th here. And then you will just have plus signs in between. Okay, that's how that works. If there's a minus sign, some people teach to do it differently. I don't. Just make b the negative number, and you only need one formula for both. So we're going to apply that here to the 4th power. This, the root 5, will be to the 4th power. It's going to be 25. So you're going to have 25, and then you're going to have plus 4 times, now the a is only to the 3rd, the a being the first term, which is the root 5, right? This is the root 5 minus 1 that we're doing. We're ignoring the 2 for now. So the root 5 to the 3rd power is 5 root 5, and then the b to the 1st power is negative 1. And then you're going to have plus 6, and it's going to be a squared, which is 5, because it's a root 5 originally, or rad 5. and then the negative 1 gets squared, which makes it not negative anymore. And then you're going to have plus 4 times, it's going to be root 5 and then negative 1 times, and then finally b to the 4th, which is just going to be plus 1. So I've got all this going on. What do we got? We got a positive 25, a positive 30, 55, and 1 is 56. And you've got negative 20 root 5 and negative 4 root 5 is negative 24 root 5. All of this is over 2 to the 4th. Don't forget that. That's 16. I quickly see 8. 8 and 8 goes into all 3. Let's simplify. 7 minus 3 root 5 over 2. This is what x to the 4th equals, right? X to the 4th equals this. Therefore, to get x to the 8th, all we have to do is square this. And that's pretty easy to do. So we're going to have a squared, which is 49, new a now, not the a we had over there. 49, the product of these two times 2. That's negative 42 root 5. And then you're going to square this, which is squaring the integer to 9, and then times the number inside the radical, which is going to be 45. It's positive because a negative squared is positive. 2 squared is 4. Again, we only have to square this because x to the 4th squared is x to the 8th. Okay, so from there, I'm going to try this one out, I guess, since the marker's getting kind of light. 49 plus 45 is going to equal 94, and then minus 42 root 5 over 4, and that in turn you can simplify. I'll do it over here actually. You're going to have 47 minus 21 root 5 over 2. Great. Let's get up to here then, because we want to plug these in. We have x to the 3rd. We'll have to do that in the moment, or will we? So we'll have the x to the 3rd out here, and inside x to the 8th is this 47 minus 21, that's 0, 21 root 5 over 2, and then this is going to be plus, I'm going to erase here so I have space, it's going to be plus, or minus rather, 7 times the x to the 4th expression, which is right here. 7 minus 3 root 5 over 2, and then we're going to have plus 1. Okay, let's clean up. We've got 47 minus 21 root 5 over 2, and then it's going to be minus or plus negative 49. Negative 7 times negative 3 root 5 is plus 21 root 5 over 2, and then plus 2 over 2. Now we've got everything in terms of over 2, which means we can just combine like terms. Let's get to that. Negative 21 root 5, positive 21 root 5, goodbye. 47 minus 49, negative 2 plus 2. Wait a minute, but that would mean that's 0. Yes, it is. And 0 times x cubed, regardless of what x cubed is, will be 0. So this is B. If you know why this one doesn't work, or if I made a mistake in my calculations when I mock solved the test, which is not on video by the way, then let me know in the comments why it doesn't work, or what I'm missing, that why it doesn't actually check out. If you have any other things to comment about, leave a comment. If you liked the video, give it a like. I'll see you guys in the next set of 5 problems.